All right, guys, welcome to another episode of Cuda Education. We are in the pipelines.cpp discussion series. This is the algorithm here. I want to mention quickly that the author of this code, Sascha Willems, has been making updates to all of his algorithms on GitHub. So the algorithm that you have that I'm working with here is a previous version of what's currently on GitHub. I assume that it's still going to generate the same thing, or it's going to be a very similar thing. It's just that he's in some cases simplifying things or making it more transparent or improving it in some way. But just be aware that my installation of the examples package that I did a while back is gonna have code that's a little bit different than maybe what's on GitHub. For this pipelines.cpp, definitely it is modified. I don't know if you want to say slightly or not, but it is modified. So big shout out to the author. As you can see here, he created a bunch of examples that are freely available on GitHub for the world to use so that they could learn the Vulkan API. So big shout out to him. If you're interested in getting these examples installed on your machine, it's a whole package of examples. Definitely check out tutorial number 1 and tutorial number 13. Tutorial number 1 is installing the Vulkan API on your Windows-based machine with a Vulkan-capable GPU. Tutorial number 13 is installing his examples. So all these is a package of examples. It's several examples, like over 30 examples, right? Or about. So definitely check those tutorials out. I'll have a link in the description below. We're moving along in this particular pipelines.cpp series. So in the previous video, we did prepare pipelines and we discussed all of that. And now we're back to descriptor set stuff. Okay, so remember, guys, descriptor sets is basically memory objects, maybe on the CPU, and we're trying to manage it for purposes of having access to the GPU and therefore having access to graphics rendering and presentation on the screen, right? That's all the descriptor set discussion is really about. It's about memory management and having access to things and what can have access to it and all of that. We already touched on descriptor sets a little bit with this setupDescriptorSet layout function, right? This is sort of a rudimentary initiation of events or functions. So the setupDescriptorSet layout, it's similar to the previous series gears.cpp that we did, but basically setupDescriptorSet layout is we're basically we're saying that we have a binding 0, we have a memory object that's a uniform buffer, it's a type of memory, and we want the vertex shader of the pipeline to have access to it. That's in a nutshell what this is. And then there's a whole bunch of like maneuvering. I don't even know how to describe it. Textual maneuvering, but it's like maneuvering and creating the descriptor set layout with a Vulkan function here. You could always Google these things, and then basically having this descriptor set layout function basically result in a VK create pipeline layout. And we take all of this information and we put it in here, and then we create when we run this VK pipeline create pipeline layout, we basically get this variable pipeline layout, and then we use that variable here in the next function. So remember, we're at descriptor set setupDescriptorSet layout. And then the immediate next thing is prepare pipelines. So if we look down here, setupDescriptorSet layout, and then prepare pipelines. Okay, so you could kind of follow, right? So we're done the prepare pipelines function here. We've sort of done that, and I discussed that in the previous video. So then now we're back to descriptor or descriptor set related stuff. So we have a descriptor pool. I have videos on descriptor pools. It's just basically resource management, right? So descriptor pool, go to definition, right? We're actually now claiming size and data, right? So we're claiming hardware resources for the descriptor set. So we know that we want, you know, we know that it's of type uniform buffer. And what else do we know? What's this one here? Let's go to it. So, and it's just one descriptor count, okay? So this is like a helper function that Sascha created. He uses it in all of his examples. So this is like a helper function, and it takes the type. So what kind of memory you're dealing with, and how many descriptors are we're expecting. So it's just one, okay? And then, you know, we do a little bit of semantics, moving around and stuff. We have this descriptor pool create info. This is all custom kind of function that Sascha created. As you can see, it's Vulkan initializers .hpp, right? So it takes a pool size, count, pool size, and max sets, right? So pool size, count, size, data, and 2. Max sets is 2. Okay, I'll leave that alone for now. And then we do vk create descriptor pool. This is a Vulkan function, and you can you could Google what this function does. It's an actual function of the Vulkan API. You could look it up in the spec. It's not something that's like specially created for this algorithm or anything. This is like, you know, the Vulkan API itself, right? So we're basically allocating now space and resources for the descriptor pool. In my whiteboard video, which I'll link down below, in my whiteboard video, I talk about the descriptor pool. It's like the highest level, highest or lowest? It's like the lowest level. It's the biggest box, right? So the way I do it in my whiteboard video, it's like boxes within boxes. So the lowest common denominator, or the baseline foundational thing, is the descriptor pool, right? Because before you could do anything, you actually have to allocate resources to it, and you know, but before anything can be achieved, you need a big box, right? And then you could put other things in there, but the big box is the container, right? So that's the way how I did it in the whiteboard, and that's what what descriptor pools are, and what this is trying to achieve. It's just basically managing hardware resources. It's like a big container, and it's outlining resources, right? The next function is setupDescriptorSet, right? So if we go to that definition, it's more of the same. So we have vk allocate descriptor set. So the descriptor pool is like the big box with our hardware resources, and then we have different descriptor sets. Okay, I discussed that in the whiteboard video, freely available on YouTube. Let's look at what this helper function. So we're building this variable alloc info, and let's look at what this helper function does. So it takes in the descriptor pool, okay? It takes in set layouts and then descriptor set count. So this descriptor pool now is, of course, the variable that if we go to definition, okay, so we initiated it there, but that variable should have been this guy up here. Okay, so remember, we fire off this function here, which is part of the Vulkan API spec, and the handle for what is created is this descriptor pool variable. Well, we take this descriptor pool variable, and then we drop it into this guy right here, right? So descriptor set allocation, and then we have our descriptor set layout, which was this guy up here. So notice that these handles are all being created after a little vk function call, which is the Vulkan API itself. So we fire off this function call, and then we have a handle for this. We fire off this Vulkan API function call, and then we have a handle for it. So we're creating a descriptor pool here. We're creating a descriptor set layout there, right? And then we're taking all of those things, and we're basically putting it into here to build this VK descriptor set allocate info variable, alloc info, okay? I know it's a little bit overwhelming, and that's why I keep going over, for each example, I keep going over the same thing over and over and over and over again. And I'm hoping that each time we go over it, it sinks in a little bit deeper in your mind, number one. And then there are slight changes with each implementation, because every example is different and it's using different stuff. So as we go over them, hopefully, something new pops up that we could learn from, something new pops up that we could understand the relationship between things, and we could see, what's going on. So again, let's look at this function call. So we have our descriptor pool variable, we have our descriptor set layout variable, and then we have our descriptor set count. So it's just one descriptor set that we're using in this situation. I don't really want to get into, so but a descriptor set is kind of like a package of information, coherent and consistent. Like, okay, we have one descriptor over here, we have another descriptor set over there, and it's different packages. Okay, we're also firing off another Vulkan API function call. Again, this is not something custom made for this algorithm. This is a Vulkan API function call, and you could Google this and the spec will tell you all about what it's doing. But again, we take our variable, which encapsulated the descriptor pool and the descriptor set layout variable, and we're using that now to put it into this function, this Vulkan API function call, and then we get another variable called descriptor set. Okay, and basically we take that again and we keep moving. So write descriptor set. So binding 0, vertex shader, uniform buffer, right? We kind of knew it was a uniform buffer from the get-go, and we kind of knew it was a vertex shader we're talking about from the get-go, because from the descriptor set layout, which is the first thing that we encountered, we talked about the uniform buffer and the vertex shader, right? So it's it's a vertex stage of the graphics pipeline that we're dealing with. So there's no surprise here, and it's binding 0, no surprise here. And then we have uniform. Let's look at this uniform buffer descriptor. Let's see what so we have descriptor set, descriptor type, descriptor set, descriptor type, right? Uniform buffer, right? And then we have the binding of 0, which is no surprise, right? And then uniform. Notice that this is pre-configured to descriptor count of 1. So we're not even setting that because it's already pre-configured in the call here. Descriptor buffer info. Descriptor buffer info. So okay, so encapsulates access to a Vulkan buffer backed up by device memory. To be filled by an external source like Vulkan device. This is in Vulkan buffer H. We'll have to get back to you on that one. The uniform buffer. Okay, this is within the pipeline. So we do create a buffer variable called uniform buffer. All right, so I will need to put some more energy into this piece of it. All right, I'll need to put some more energy into this call right here. Yeah, I kind of missed it. All right, yeah, I will have to, but notice that the final result is this VK update descriptor sets. And it's almost like to create the descriptor set, it's like you have to call this update function, which I found kind of weird and off-putting, but it is what it is. Okay. Can we go to definition for this? Device, descriptor write count, descriptor writes, descriptor count, and descriptor copy. So that's this piece right here. I probably will have to make another video to elaborate more on these two things right here. But this is the descriptor. This is the setup descriptor set. So it's kind of like the final piece of the descriptor set. I will put some more energy into it. This is why this video is freely available on YouTube. But yeah. So after we finish with this piece, right, in the list of function calls, I'm just going to combine all these three things. Or maybe I shouldn't. I think I will probably just leave it at that. So we have our descriptor, setup descriptor set layout, setup descriptor pool, and then setup descriptor set. But the most important thing is that we're all the final end all and be all of it is this VK update descriptor sets, because that's encapsulating all of the work that we did before to fire off this function, so that we actually create the descriptor sets and we could use it and do whatever we need to do after that. So I think I'm going to break the video here, especially because I have to put some more energy into this piece right here and also elaborating more on this piece. Okay, so I thought I was just going to breeze through this like I did for the previous videos, but alas, it's a little bit more involved, which is a good thing because we're all learning, right? And that's what we want. So yeah, that's it, guys. So you know my usual thing: like and subscribe, ring the bell. I'm trying to push out these videos at a steady pace. Please check out the Vulkan spec. Please check out Sascha Willems' website. Definitely check out tutorial number 1 and tutorial number 13 so you could participate in this in a real way. If you know anyone that's artistically inclined, at anywhere that you come across them, encourage them to learn about the Vulkan API. All of my tutorials, everything I do doesn't assume any programming experience. Okay, so I'm not here trying to use terms that no one understands or trying to do things that no one understands. In the tutorials, it's basically me trying to set up everything on for the Vulkan API on your Windows-based machine with a Vulkan capable GPU, and then installing the examples. Once you have the examples installed, you have free reign. You could do whatever you need to do. You could tinker with the code. You could mess around with the different examples. There's many examples, right, with many things going on. And then that's where the real learning occurs, right? You also have the Vulkan spec, which is freely available. It outlines everything, all of these variable types, all of the Vulkan functions, the Vulkan API functions. It's not necessarily that it's complex. It's just that, when you're trying to teach a computer to render stuff, when you're trying to teach a computer to present things to the screen, you have to communicate a lot of things. And that's all it is. It's just a communication thing. Not only communicate, but also giving you as the programmer options so you could communicate, very nuanced and subtle things and communicate it very explicitly, right? So, it's not like you say one thing and then there's a whole bunch of other things that are done for you. You have to literally outline everything step by step that you need to do. And that's pretty much it. So get to it, guys. If you play video games, if you're a gamer, that's cool. But also learn, start on the journey of learning how to build your own video game, build your own renderer, your own game engine, everything, right? And maybe one day you could get paid for it. And even if you're not creatively inclined, just learning how to program a computer, learning C++, learning Visual Studio, learning how a computer works and how you could get it to do whatever you want it to do is a powerful thing. So there you go, guys. Stay positive, commit yourself to self-improvement, and keep it moving. Every day is a new opportunity. All right, guys, that's my spiel. This is Cuda Education. Thank you guys for watching. Until the next time.